You're not in this class?
No, sir.
Did you watch the recording, Sarah?
Sir, I didn't have time.
Achha. So just write a few relationships, okay, Sarah? We'll be using that today. So you know waves, right? Correct?
Yeah.
So waves have frequency, wavelength, and speed as they are propagating. Next, what you need to do is the relationship between these. The speed that we are going to take for electromagnetic waves is a constant that is equal to c, which is equal to 3 into 10 to the power 8 meter per seconds. Okay. And the relationship between all of these things, this is equal to, please see here. Here we have wavelength, which will be in terms of meter, frequency will be in terms of per second. So what we can write? We can write that c is equal to, c will be equal to speed is meter per second, right? So it will be equal to wavelength, that is lambda into nu. So frequency will be equal to c by lambda. This is for frequency, which will be in hertz and per second and so on. This is speed of light, 3 into 10 to the power 8. This is lambda is for wavelength.
Done, sir.
And then another relationship, that energy, it is equal to Planck's constant multiplied by nu. Assalamu alaikum, Yasir and Kashif. How are you guys? यासिर एंड काशिफ, माइक नहीं ठीक हुआ क्या अभी तक आप लोगों का? Yes, alhamdulillah, I'm also good. Siddiqa is here. Why are students so late today? चलिए. Acha, okay, fine. Acha, by the way, those who were present in the last lecture, tell me what is the value of h, the Planck's constant? Yasir, Kashif, Martin, anyone? Siddiqa, Planck's constant, tell me the value. Yes, 6.626 into 10 to the power minus 34 joule seconds. Joules and seconds, okay? Not joule per second. Kashif, not joule per second, it is joule second, joule into seconds. No. जी, no problem. Chali. This was just for those who were not present in the last lecture. Now, today's topic starts with photoelectric effect. Now, we'll understand photoelectric effect, and it is one of the most important experiments that led towards the Bohr's model. What is photoelectric effect? Please write with me, and then I will explain. The ejection of electron from metallic surface when the light of suitable frequency strikes the surface, ejection of electron from metallic surface when the light of suitable frequency strikes the surface is called photoelectric effect. Now, please see what happens actually in photoelectric effect is something like this. When we have a frequency of, oops, my God, this is so big. See here, what we are doing, we are having a metal surface. This is the metal plate, and metal, it has proton, it has atoms, so obviously it is going to have protons and electrons. And when a electromagnetic radiation was struck on the surface, then what did we see? We saw ejection of electron. What did we saw? We saw ejection of electron. Now, how was this experiment conducted? Obviously, you cannot see electrons, right? You cannot see electrons. So how was this conducted? Please wait for me. Let me, this is a good. Okay, no, not this one. No, these are quite complex. Wait a second. Need a simple one for you guys. I think this is going to work. Now, please see what was happening here. We had a electrical circuit, and that electrical circuit was not attached with any battery. And then what did we have? We had a metal surface. We strike light upon it. And when we change different frequencies, for some frequencies, what happened? The voltage was shown to be something. The voltage must be 0. Why? Because we don't have any battery. But even if we don't have any battery, on certain specific wavelengths of light, electrons got ejected, and there was some electricity inside the wires, and then we saw some kind of current shown in the ammeter. Okay, some kind of current was shown in the ammeter. Now, that means some certain frequencies of light, they were able to eject electrons, and those electrons went in this direction and they flew as a current inside the path of the wire. Now, what does this mean? It means, please write next. Certain frequencies of light they are able to eject electrons from metal surface. This was seen. Now, each and every frequency of light, it bears some energy, and that energy is known as, that energy can be given by E is equal to h nu. This is the frequency multiplied by the Planck's constant. We will get the energy of that particular wavelength or that particular frequency. Now, please write next. The minimum amount of energy.
First heading.
No, not the heading. The heading, what we are going on is photoelectric effect. Okay, we're still in the photoelectric effect. The minimum amount of energy required by electron to cause photoelectric effect. PE means photoelectric effect, is called threshold energy or work function. So threshold energy denoted by W or E naught. Threshold energy or work function will be equal to H naught. Now, mu naught is the threshold frequency. The frequency at which photoelectric effect occurs, that is threshold frequency. Then we can write mu as C upon lambda. Now, C is a constant, wavelength changes. So this wavelength is threshold wavelength. Let me know.
Sir?
I'm sorry, guys. Today my internet is not very good. I mean, I don't know what's happening, but it is getting disconnected. My Zoom is getting disconnected. This was happening too often in the last class. Fair. All of you are done?
Sir? Could you explain the experiment again?
I will explain the experiment again. आपने लिख लिया?
Yes, sir.
All of you, please don't write anything. And then we are going to look at the experiment. Now we have a few terms with us. Now that is why I was writing these things first, then I will explain. That means threshold frequency, threshold wavelength, and so on. See. Till now, what we have covered, I just want to bring into your memory what we have done till now. We have been able to know that there are electrons inside we have been able to know that there are electrons inside the atom from the cathode ray experiment, right? From the cathode ray experiment. Now, electrons are there, and we also know that protons are there. Not protons exactly, but we have a nucleus which is positively charged from the gold foil experiment, J.J. Thomson. Nucleus is there, which is very tiny. Okay, and we know that electron is there, and this nucleus is positively charged. Now, this nucleus, it is in the center. We know that much. And then we also know that each and every atom, it has a very large amount of vacant space. This is a very tiny, miny nuclei. Okay. Now, their electrons must be somewhere, but we don't know where the electrons are right now. J.J. Thomson is up. No, not J.J. Thomson. Rather, Rutherford, he suggested that here we have the nucleus. And as we have the different planets orbiting the sun, the electrons are also orbiting the protons. But in the last class, we saw that if this was actually happening, then as a particular charge, if I have a positive charge and around it there is a negatively charged particle which is revolving, then eventually what is going to happen, it will spiral down like this. And it will collide inside the positive charge. But obviously, as we know, each and everything is made up of atom. Each and every matter is made up of atom, and nothing is colliding. And this collision would take only 10 to the power minus 8 seconds. That means 10 nanoseconds. Under 10 nanoseconds, if the Rutherford's theory, if the Rutherford's model of atom was correct, then the complete universe would be off within 10 nanoseconds. But obviously that is not happening. That means the Rutherford model was not correct. We don't know what is the status of electron, how the electrons are present, how the electrons are stabilized inside the atom. So for this, we were doing a few experiments, और वहां पे एक experiment ये आया about the photoelectric effect. We know that there is a positive charge nuclei, and we know that we have electrons which are negatively charged. So obviously there will be some attraction between these two. Correct, guys? Yes or no? Please tell me.
Yes, sir.
Now, if I want to break this attraction, I have to put in some energy, right? किसी चीज को तोड़ने के लिए आपको एनर्जी लगेगी ना. दो चीज अगर अट्रैक्टेड है, if you remember, if you have played with magnets, when the magnets are joined together, है ना? If two magnets are joined together and if you are going to pull it away, then you require some energy. Correct, guys?
Yes, sir.
Yes, sir.
बाकी लोगों को समझ में आ रहा? सिद्दीका, यासिर, काशिफ,
Yes, sir.
सारा, ठीक है? Now, that's what was happening when we had the photoelectric effect. We know that frequencies of light, different wavelengths of electromagnetic radiation, they possess some kind of energy. What energy? That can be determined by E is equal to h nu. They have some energy, and when a frequency of suitable, when a light of suitable frequency or suitable wavelength was struck on the surface of metal, then what happened? This electron, it absorbed that energy and it got away. Another electron, it got the energy from the wavelength and it got away. हमने इतनी energy दे दी कि जो attraction था between the positively charged nucleus and the negatively charged electron, that was broken off, and that is why electron got away from the interference of any nucleus, from the attraction of any nucleus. Is this clear? Yes or no, plot? Yes or no, please tell me.
Yes, sir. Yes, sir.
Similarly, and this was ये experiment actually, this was what was happening, but experiment में क्या choose किया गया था? We had a metal surface here, ठीक है? इसमें we strike light, and we had a complete circuit like this, और यहाँ पे एक ammeter लगा हुआ था, which shows you if the current is flowing or not. So obviously the circuit is open. सबसे पहली बात, ना, the circuit is open, and we have a gas chamber like this. The circuit is open, so obviously there should be no current passing, and also we don't have any power source. Power source भी नहीं है. But as soon as we strike light on this particular metal, electrons, they got ejected, and electrons got ejected with some kinetic energy. That is why they were able to reach this particular electrode, and some current flew in the ammeter. And when some current flew in the ammeter, this was the proof that some ejection of electron is going on. सबको बात समझ में आ गई? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
Yeah. Let us look at a few data. Okay. Work function data. And from that data, we will get to know many things. So we have a good amount of data. Can you guys see this work function? Yes or no? Please tell me. We know the work function, that is the minimum amount of energy required to. Now, since we have understood this, we will, what is photoelectric effect? Minimum energy required to remove electron from attraction of nucleus. सही है? लिख सकते हैं ना photo. What is work function? Minimum energy required to do photoelectric effect. And what is exactly photoelectric effect in the molecular level, in the atomic level? In the atomic level, the electron is getting away from the attraction of nucleus. सही है guys? Yes or no? Please tell me. अरे हाँ ना, कुछ तो बोले.
Yes, sir.
नहीं आया. आया नहीं आया? सिद्दीका आया
No,
आपको?
sir.
नहीं आया आपको? वर्क फंक्शन आपने सुना था? वर्क फंक्शन नहीं सुना आपने?
No, sir.
अरे तो यही तो लिखने के लिए कहा हमने आपको. वर्क फंक्शन नहीं लिखा? The minimum amount of energy required by electron to cause photoelectric
Yes,
effect is called threshold energy or work function, है ना?
Yes.
Or photoelectric, what is photoelectric effect? We just saw photoelectric effect is nothing but removing the electron from the attraction of nucleus. Correct ना?
Yes, sir.
सही है? Everyone is with me,
Yes.
right? ठीक है, चलो. काशिफ और यासिर, you guys are with me? जी, चलिए, बहुत बढ़िया. Okay, now we have this in terms of electron volts. Electron volts is just a unit for energy. आप उस पे गौर नहीं करेंगे. We are now looking at the numbers. Okay, so we have 4.08 for aluminium. We have 4.08 for aluminium and 5 for beryllium, 4.07 for cadmium, 2.9 for calcium. For carbon, we have 4.81. Now, I want to look at a few particular things. जैसे कि आप मान लीजिए, we have aluminium and beryllium है, cadmium है, beryllium है, magnesium है. किसी एक हमको I need for one group, one particular group. सर अभी तो आप लोगों को ग्रुप और you know about groups and periods in periodic table नहीं पता आप लोगों को. You have not seen a periodic table in the class 10th standard, right? It was removed from the syllabus.
Yeah.
Yes, sir.
लेकिन आपने, मतलब आपको कुछ आइडिया है ग्रुप्स का? What is a group? What is a period? No idea.
No, sir.
No, sir.
Okay. फिर भी चलिए. Let us see. Let us take calcium, beryllium, calcium, magnesium. Then we have strontium somewhere. No strontium. We are going to take these three: beryllium, magnesium, and calcium. All of you are aware of the atomic number for these, right? Yes or no? Please tell me. Hannah?
Yeah.
What is the atomic number for beryllium?
4,
For magnesium?
11,
11.
12,
Calcium?
20.
Okay. Now, you also know that if I talk about the beryllium atom, then beryllium is going to have 4 electrons. You have a positive charge. In the first shell, there will be 2 electrons. In the second shell, there will be 2 electrons. Correct? So, yeah.
Yes, sir.
Now, What will happen in magnesium? You have a positive charge, then we have 2 electrons here. Then we have how many electrons? 8 electrons
8.
here. And then in the outermost shell, how many?
2.
2 more. What will happen to calcium? In calcium, we will have a positive charge here. Then 2 electron here. After that, we will have 8 electron and then 8 electron again, right?
Yes, sir.
And then 2 electrons. Now, as you can see, the electron in the beryllium, it is very near to the nucleus. दिख रहा है आप लोग को? Right, guys? It is in the second shell.
Yes, sir.
And then positive charge. In the magnesium case, it is in the third shell. In the case of calcium, it is in the fourth shell. Can you see that? This is the first shell, second shell, third shell, and fourth shell. Here we have 1, 2, and third shell. Here we have only 1 and 2 shell. Now, the electrons and protons, the charges are near which? सबसे ज़्यादा नज़दीक कहाँ पे? Beryllium में है. Correct, guys? It is nearest in the beryllium. So it will be very difficult to remove the electrons from beryllium, right? Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Can you see? It requires 5 electron volts. Magnesium requires a bit less, 3.68 electron volts. Calcium requires even less, 2.9 electron volts. So now you understand what is photoelectric effect and work function and how it is related to the electrons present in different atoms and electrons present in different shells of our atom. दिख रहा है आप लोगों को? नहीं दिख रहा है? Can you
Yes,
relate
yes,
this? Yes or no? All of you can relate this ना? ठीक है, चलिए. Now, this was just to show you guys. या ऐसे मतलब आपकी ना पूछा जाएगा इसके बारे में, but लेकिन आपको लगेगा ना कि सर photoelectric effect अचानक से, मतलब in the second chapter you will see things coming अचानक से ही, है ना? Photoelectric effect अचानक से ही आ गया. Now you understand why we are having photoelectric effect, because photoelectric effect is giving an idea about the distance of electron from the nucleus. अभी शेल नंबर तो नहीं आया ना, बोर मॉडल में था शेल नंबर, है ना? तो शेल नंबर हम लोग अभी नहीं बात करेंगे, because we don't know whether we have shell or not. अभी हमारे नॉलेज में तो है, but we are talking in terms of the timeline of the atomic structure. How did the atomic structure came into being? So now what we can say, the work function gives an idea about the distance of electron from the nucleus. Correct है? Yes or no, guys?
Yes, sir.
आगे बढ़े अब, ठीक है? तो ये आपको पता चल गया. अब जो काम की चीजें हैं आपके टेस्ट के लिहाज से, एग्जाम के लिहाज से, उनको देख लेते हैं, है ना? नाउ we have seen work function. ये सारी चीजें आपको लिखने की जरूरत नहीं, बट जस्ट you should know कि क्या हो रहा है एक्चुअली. थ्रेशोल्ड एनर्जी तक लिख लिया आपने, उसके बाद नेक्स्ट लिखिएगा. Lower the work, next point, no heading, okay? Lower the work function, easier is ejection of electron. Easier is ejection of electron. Now, next point is more important. If the energy of light is greater than work function, then the extra energy will be converted as kinetic energy of electron.
Sir, the heading.
Heading, अरे same heading है भाई. We are still in the photoelectric effect. Heading change होगा, हम बता देंगे.
Yes, sir.
कंटिन्यूटी ना, थ्रेशोल्ड एनर्जी था, है ना? वहीं से लोअर द वर्क फंक्शन और थ्रेशोल्ड एनर्जी, उतना ही आसान होगा इलेक्ट्रॉन का निकालना. ठीक है? Now, if E is the energy of light that we are sending, this will be equal to the work function and the kinetic energy that is possessed by the ejected electron. ठीक है? If E is the energy, then उसमें some energy will be used for the ejection of electron, और ejection के बाद जो kinetic energy, some of the energy will be used for the kinetic energy. So how much kinetic energy will be there for different types of electrons? So we can see here, kinetic energy will be equal to the energy of light that we are sending minus what is used as ejection of electron. देखिए प्लीज ध्यान रखिएगा, जब इजेक्शन होता है इलेक्ट्रॉन का, इट इज यू आर नॉट श्योर दैट इट इज गोइंग टू हैव सम काइनेटिक एनर्जी, बिकॉज इफ यू आर गोइंग टू गिव only the energy that is equal to work function, तो सिर्फ ejection होगा, that electron will not have any kinetic energy. But if you are giving energy greater than work function, then that electron will be ejected, and it will be ejected with kinetic energy. Okay, so for E I can write E is equal to h nu, and for work function, if you have seen earlier, it is equal to h nu naught. And from here you can write kinetic energy is equal to Planck's constant multiplied by mu minus mu naught. Okay, now please write conclusion. Please write here. When light strikes metal, a few things can happen. यहाँ तक लिख के आप छोड़ दीजिएगा, अभी कुछ मत लिखिए. Few things can happen when light strikes metal. We have a light, the light will possess some energy, right? When you have E, that means the energy that is possessed by light, that is less than work function. ठीक है? Then in that case nothing happens. Why? Because no ejection will happen, because आपको minimum energy आपने दी ही नहीं. So I will write nothing happens. No PE, no photoelectric effect. Now, next case is when you have the energy of the light that is equal to work function. So you have given the minimum amount of energy to eject the electron. So only the electron will be ejected. Electron is ejected. With zero kinetic energy. And what will happen in the case if the incident light with energy E is greater than work function? तो क्या क्या होगा? If it is greater than work function, then electron will be obviously ejected, and it will be ejected with some kinetic energy. सबको बात समझ में आई? हाँ या ना? बिल्कुल ऐसे शांत हो जाते हैं, हमको लगता है आप लोगों को कुछ समझ में नहीं आ रहा. सिद्दीका, सारा, यासिर, काशिफ आया? आ रहा है ना? हाँ, तो यस सर, नो सर, प्लीज बोलते रहा करें. Now, I hope you have written. लेकिन एक चीज बस हमें देखने दीजिए. लास्ट क्लास में हमने आपको वो शॉर्टकट बताया था कि नहीं एनर्जी.
1 second, sir. I'm still writing.
एक सेकंड. ठीक है, ये आपको हमने बताया हुआ ना, E is equal to 1240 इलेक्ट्रॉन वोल्ट बाई लैम्डा, है ना, अगर इलेक्ट्रॉन वोल्ट में दिया हुआ है तो. एंड 1 इलेक्ट्रॉन वोल्ट इज 1.62. ठीक है, चलिए हम बस ये देखना चाहते हैं हमने बताया है कि नहीं बताया. प्लीज राइट, एंड देन हु आर डन they will write a question. A light bulb having wavelength 62 nanometer strikes the metal surface. The work function of metal surface is 13 electron volt. Calculate the kinetic energy of ejected electron. लिख लिया आप सबने ना? प्लीज सी. Now, as soon as you get any numerical, you have to do a few things. आप ऐसे पढ़िएगा numerical. A light bulb having wavelength 62 nanometer. That means lambda is given as 62 nanometer. Strikes the metal surface. The work function of metal surface is 13 electron. That means they have given W is equal to 13 electron volt. Calculate the kinetic energy of ejected electron. Kinetic energy पूछा हुआ. Kinetic energy is equal to how much? Now we have one formula of kinetic energy. As soon as you have been given lambda, you can calculate the energy, and this will be equal to 1240 divided by what? 1240 divided by lambda. सही है? Is there any change that we have to do? Tell me, guys. कुछ change करना पड़ेगा या फिर सही है?
Yeah, right.
आपको सही है? देखिए, whenever you are writing 1240 ना and divide by lambda, I hope यहाँ पे लिखा हुआ हमने E is in electron volt and lambda is in nanometer. ठीक है ना? तो nanometer में तो आपको दिया हुआ है, इस वजह से that means we can directly write this. It will be equal to 1240 divided by 62, and the energy that you are going to get, it will be in electron volts. This will be equal to how much? 62 का double हो जाएगा ना? I think this will be 20 electron volts, right? Correct है? है ना? बताएं. ठीक है. And what is kinetic energy? Kinetic energy is equal to energy that is of light minus the work function. Energy of light जो हमको मिली वो क्या थी? 20 minus what is the work function? 13. And this will be equal to how much? 12 minus 13, that is equal to 7 electron volts. ठीक है. All of these things it became very easy because of this formula. ठीक है, याद रखिएगा. इतना आसान हमेशा आपको नहीं मिलेगा, और अगर आपको ना मिले ना तो आप हमेशा इसमें कन्वर्ट कर लीजिएगा 1240 में. ओके, बिकॉज अदरवाइज E will be equal to HC upon lambda, which is equal to 6.626 into 10 to the power minus 34 into 3 into 10 to the power 8 divided by lambda will be 62 into 10 to the power minus 9. ठीक है. अब इसके बाद जो कैलकुलेशन आएगी ना वो होगी आपकी एनर्जी, बट बिकॉज वी हैव अ शॉर्टकट फॉर लैम्डा, जब लैम्डा किस में हो? नैनोमीटर्स में हो, एंड एनर्जी आपको इलेक्ट्रॉन वोल्ट्स में मिल जाएगी. सो इन दैट केस वी हैव अ शॉर्टकट. ठीक है. सो ऑलवेज ट्राई टू convert lambda into nanometers and then do 1240 by lambda. You will get the electrons, you will get the energy in electron volts. अगर उसको जूल में कन्वर्ट करने की बात आ जाए, so for example I am getting 7 electron volt, then this will be equal to 7 into the charge on one electron is equal to 1.6 into 10 to the power minus 19 joules. So this will be the energy in terms of joules. ठीक है. So joules में कन्वर्ट करना आसान है, आप हमेशा क्या कीजिए? नैनोमीटर में कर लिया कीजिए लैम्डा को. All of you got this? Yes or no? Please tell me.
Yes, sir.
Yes,
Yes,
sir.
sir.
Now, we have seen a numerical. We have also seen how to interpret the photoelectric effect. Correct, guys? Yes or no? Please tell me. Now, see next. From these photoelectric effect, Bohr he actually said that like here, Bohr's model of atom. कहानी को आगे बढ़ा रहे हैं ना. Bohr's model of atom. As we saw that different metals they have different work function. ठीक है. यानी कि हर एटम की हर एटम में जो इलेक्ट्रॉन है उसकी एनर्जी अलग है। देन ही सेड दैट नहीं, एनर्जी अलग होने का मतलब ये है कि जो बेरिलियम का जो इलेक्ट्रॉन है वो थोड़ा दूर है, मैग्नीशियम वाला उससे और ज्यादा दूर है, तभी आसानी से निकल जा रहा है। इट इज अवे फ्रॉम द न्यूक्लियस, दैट इज व्हाई इट इज इजी टू ब्रेक ऑफ, it is easy to break the attraction between nucleus and electron of magnesium than beryllium, और उससे भी आसान है कैल्शियम का। So he saw a trend and he said that what actually is happening is this. Please write with me. He said electron, or rather electron is revolving in circular path around nucleus called orbit or shell, called orbit or shell, or energy level. Then the next one was very important. He said that if the electron is present in a particular orbit, then it can neither radiate energy का मतलब lose energy, nor absorb energy, that means gain energy. So the energy of each orbit is fixed. Energy of each orbit is fixed. Now, it is saying that it is not neither going to radiate, lose energy, or it is neither it is going to gain any energy. If it is present in a particular orbit, क्या मतलब है इसका? जैसे ही उसने कोई एनर्जी लूज की उसका ऑर्बिट चेंज हो जाएगा, जैसे ही उसने कोई एनर्जी गेन की उसका ऑर्बिट चेंज हो जाएगा। ठीक है, दैट इज द मीनिंग। ऐसा नहीं कि वो एब्जॉर्ब कर ही नहीं सकता है, इट डज नॉट हैव एनी कैपेसिटी टू डू, इट डज नॉट हैव एनी कैपेसिटी टू डू, it does not have any capacity to either lose energy or gain energy and also be in a particular orbit. ठीक है, please understand this. I'm not saying, neither Bohr said कि वो energy absorb कभी भी नहीं कर सकता है, उसका कहना था it cannot absorb or lose energy if it wants to be in a particular orbit. अगर उसको orbit change करना है तब energy lose या gain कर सकता है। Is this clear? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
Yes, sir.
Right, next. Energy of electron changes with energy of electron changes with change in its orbit. ऑर्बिट चेंज कीजिए तो क्या होगा, एनर्जी उस इलेक्ट्रॉन की चेंज हो जाएगी। प्लीज सी नेक्स्ट। Right, next, the transition of electron, the transition of electron from one orbit to another, from one orbit to another, from one orbit to another is accompanied with change in energy. ठीक है, so for example, you have an electron that is in a shell number 1, ठीक है, शेल नंबर या फिर उसको फर्स्ट शेल, ऐसा नहीं बोल रहे हम कि पहला शेल है, दूसरा तीसरा कुछ भी हो सकता है, फ्रॉम एनी शेल 1 टू एनी अदर शेल 2, ठीक है। सो दिस इज अ ट्रांजिशन फ्रॉम वन शेल टू अनदर, है ना। फर्स्ट शेल और सेकंड शेल नहीं बोल रहे हम, फ्रॉम वन शेल टू अनदर, then this change can be shown as E2 minus E1, and this will be equal to H.
So what's the difference between H nu and H nu 0?
Oh, H nu 0 is the work function. वो that is the frequency जहाँ पे इलेक्ट्रॉन पूरा का पूरा बाहर निकल जाएगा. It will be away from the attraction of nucleus. ठीक है? And mu is just any energy, any frequency. That is not necessarily the frequency that is required to get the electron away from the attraction of nucleus. It is the generalized form. Is everyone done? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Now, there are a few things regarding Bohr's model जो हमको देखना है, and इसमें आप लोग लिखिएगा mathematical analysis of Bohr's model. ठीक है? Now, there are a few things that I'm going to write. घबराइएगा मत आप, ठीक है? अभी उनको पढ़िए, ठीक है? And then slowly those will make sense. Now, he first of all gave the radius of an orbit. Now, radius of an orbit was given by as radius of nth orbit will be equal to n square h square divided by 4 pi square m into e square. What are these things? N is the orbit. This was only for hydrogen. This was for hydrogen. Okay, this was for hydrogen. Now, what is this Rn? R is the radius of nth orbit. N is the orbit. H is the Planck's constant. 4 is a constant. Pi is a constant. M is the mass of electron. And E is the charge on electron. ठीक है? Is this clear? Yes or no? Please tell me. यहाँ तक अब देखिए. Don't worry about this. ठीक है? Don't worry about this. Please see here. What is important? This is for hydrogen atom, and Rn for any other atom will be equal to n square h square divided by 4 pi square. ये आपको याद नहीं करना है. me square into z. Now here we have a new term, that is z. Z is the atomic number. हाइड्रोजन के लिए तो 1 होता है, that is why z का वैल्यू वहां पे 1 है, so that is why we don't see it, but this is for generalized thing. ठीक है? This is for hydrogen like atom. हाइड्रोजन like मतलब क्या? Since Bohr only gave ना, Bohr के पास सिर्फ solution था किसका? 1 electron system का. ठीक है? He was able to explain completely and mathematically 1 electron system. So he gave the model for hydrogen, which was having 1 electron. Then if I look at helium positive, we have removed, helium has 2 electrons, remove 1 electron, we have got helium positive. So this is also hydrogen like atom. Similarly, lithium 2 positive. This is also hydrogen like atom. And so, इसी तरह की चीजों की बात हो रही for hydrogen like. Now important thing is that Planck constant एक constant है, 4 एक constant है, pi square constant है, mass of electron, charge of electron, ये सारी चीजें एक constant है. and their value comes out to be, अब ये चीज आपको याद रखनी है, is equal to 0.529 into, here we have n square divided by z. And this value will be in terms of angstrom. ठीक है, अब जो रेडियस आएगा आपका, that will be in terms of angstrom. ये याद रखिए, it will be in angstrom. So this is something that you have to remember. Please write this down. Let me know if you're done.
Done, sir.
Done? Sunya.
Sir, I'm writing the formula.
लिख आराम से लिख.
Yeah, done, sir. For first orbit of hydrogen atom, we can write for first orbit, that means n is equal to how much? 1. Correct है guys? Yes or no, please tell me. है ना? First orbit का मतलब n is equal to 1. And what will be the value of z for hydrogen? What will be the value of z for hydrogen? ठीक है, plug in कीजिए. कितना आ रहा है आंसर बताइए. What is the radius? Plug in कीजिए, इसमें आंसर बताइए for first orbit of hydrogen atom. क्या नहीं आंसर आ रहा है? बच्चे डर जाते हैं. अरे n की जगह 1 लिखिए. आया सारा? नहीं आया?
0.5.
हाँ, 0.529 into n स्क्वायर की जगह 1 स्क्वायर और 1 की जगह 1 एंगस्ट्रॉम. सो ये तो कैंसिल हो जाएंगे, 1 तो 1 ही रहेगा. दिस विल बी 0.529 एंगस्ट्रॉम. करेक्ट है गाइस? यस और नो, प्लीज टेल मी. एनी प्रॉब्लम?
Yeah.
सिद्दीक, आसान है ना? ठीक है, अब ध्यान दीजिए,
Yes,
इससे
sir.
कंक्लूजन जो आपको याद रखना है. एक तो ये आपको याद रखना है 0.529 अगर हाइड्रोजन के बारे में नहीं कुछ दिया हुआ है. ठीक है, नाउ लेट अस सपोज, प्लीज सी, if R1 of hydrogen atom is equal to सम नंबर आपको दिया हुआ है, कुछ नंबर दिया हुआ है a, whatever be the unit, नैनोमीटर, जो भी कुछ दिया हुआ है वो यूनिट होगा. a is a number with unit. ठीक है, वो क्या दिया हुआ है? रेडियस ऑफ द फर्स्ट ऑर्बिट ऑफ हाइड्रोजन एटम. ठीक है, देन द फॉर्मूला फॉर रेडियस ऑफ एन ऑर्बिट ऑफ एनी एटम विल बी इक्वल टू a times n square divided by z, whatever be the unit, nanometer, angstrom, millimeter, कुछ भी यूनिट हो जाए. Because can you see the pattern here? This 0.529, it is actually representing what? The radius of the first orbit of hydrogen. है ना? तो आपको दिया हुआ है as a, कुछ भी नंबर दिया हुआ है a, उसकी यूनिट कुछ और. This is specifically for angstrom. When we are going to nanometer, then it is going to be something different. ठीक है, इसको लिख लीजिए आप पहले, and then we will do a question.
Done, sir.
Done? अब देखिए, write a question. If the radius of first orbit
of hydrogen atom is x. Is what? It is x. आपको दिया picometer. Then the radius of fourth orbit will be option A 4 into x picometer. Option B 10 into x picometer. Option C 12 into x picometer. Or option D 16 into x picometer. Send your answer in my Zoom chat. कितना टाइम दें आप लोगों को? 2 minutes will be enough now. Giving you guys 2 minutes for this. ठीक है, आसान सवाल है. आप लोग को बस दिमाग ऑन रखना है. ठीक है, दिमाग ऑफ रखिएगा, फिर बताइए ओ माय गॉड सर इतना आसान सवाल था. 2 minutes is going to be enough. हाँ जी, हुआ नहीं हुआ? किसी का आंसर नहीं आया. इतना आसान सवाल था, बताइए. इफ रेडियस r1 ऑफ रेडियस ऑफ द फर्स्ट ऑर्बिट ऑफ हाइड्रोजन एटम इज इक्वल टू a, तो ये फॉर्मूला लगाना है. यहाँ पे हमने x डाल दिया, x डालिए और n4 डालिए, आ जाएगा. हाइड्रोजन का z तो 1 ही रहेगा ना. आसान सवाल था, बताइए. 2 मिनट खत्म भी होने वाले. 9 सेकंड, 8 सेकंड, 7, 6, 5, 4, 3, 2, 1. टाइम.
Sir, my answer is not going.
मार्टिन ने भेजा है. और किसने भेजा? सिद्दीका ने भेजा. किसने भेजा?
I know the answer, but on the chat it's not sending. I don't know why.
अरे ABCD बोलिए ना. आप ABCD भेजिए. क्या हो गया?
I wrote, but it's not coming.
अच्छा, ठीक है. चलिए, अब तो आप आंसर बोल दीजिए. बाकी किसी का तो नहीं आया. जी बताइए, आंसर कितना आया सारा?
D.
वेरी गुड. आसान था. Radius of the fourth orbit will be equal to, what is the radius of the first orbit of hydrogen atom? It is given as x picometer, है ना. आपने x picometer लिख दिया, multiplied by n. What is n? The number of orbit number is 4. 4 का square. हाइड्रोजन एटम की बात हो रही है तो डिवाइड बाय 1, because z for hydrogen atom is equal to 1. So this will be equal to how much? 16 into x picometer. बात आ गई समझ में? हाँ या ना, जल्दी बताएं. तो यहाँ पे देखिए, for same atom, yeah, for same atom, for same element is better. For same element, what we can write? The radius is directly proportional to n squared, है ना. Radius is directly proportional to n squared because z is not going to change. For different element, R will be directly proportional to n square divided by Z, because वहां पे Z चेंज हो जाएगा. ठीक है. फॉर एग्जाम्पल एक सवाल अगेन, A इज इक्वल टू, A क्या होता है आपका, रेडियस ऑफ द फर्स्ट ऑर्बिट ऑफ हाइड्रोजन. A इज इक्वल टू x पिकोमीटर दिया हुआ है. फाइंड द रेडियस ऑफ, find the radius of third orbit of lithium atom. ठीक है, third orbit of lithium atom. So when I say third orbit, then in that case n will be equal to 3. When I say lithium, that means Z will be also equal to 3. So what will be the radius of the third atom of lithium? It will be equal to A, that is x picometer, multiplied by n square. N square is 3 square, divided by 3. That is the value of Z. So 3n square will cancel each other. You will get this as 3x picometer. समझ में आ रही है? हाँ या ना, जल्दी बताएं.
Yes, sir.
Yes, sir.
Similarly, write next part. That is the energy of electron. Just wait a second. Huh? Energy of electron. Energy of electron. यहाँ पे आपको हम क्या बताइए, एक्सप्लेन करें कि एक्सप्लेन नहीं करें? You can do both the things. क्या किया जाए, समझाया जाए आप लोग को या फिर ऐसे आगे बढ़े? बताइए. It's better that you remember the values. ठीक है, एनर्जी ऑफ इलेक्ट्रॉन्स के लिए ये आपको समझ में आ जाएंगी बातें. ठीक है, एनर्जी ऑफ इलेक्ट्रॉन इट इज इक्वल टू, देखिएगा, -13.6 डिवाइड बाई, -13.6 इंटू Z square divided by n square. This will be electron volts per atom. In terms of, this is electron volts. Okay. The energy of electron in the nth orbit of an atom with atomic number Z. Z अभी भी atomic number. This is in terms of electron volts. Please write next. Energy of a electron in the nth orbit will be equal to -1312 into Z square divided by n square. This will be in terms of kilojoule per mole. Done everyone? Yes or no? Please tell me.
No, I'm doing.
Yes.
ठीक है, so सुनिए. See, what is this negative
Done.
signs denoting? Like, if you, whenever you have positive and positive, there will be repulsion. If you have negative and negative, you will have repulsion. If you will have positive and negative, then there will be attraction, right? Correct? Correct, guys? Yes or no? Please tell me.
Yes, sir.
ये आपको पता है ना? Same signs repel each other and opposite signs they attract each other. Now this negative sign shows that this energy of electron is because of the attraction between the positively charged proton and the negative charge of the electron. बात समझ में आ गई? हाँ या ना, जल्दी बताएं.
Yes, sir.
नेगेटिव साइन क्या बता रहा है? सिर्फ और सिर्फ It is only telling you about the attraction between electron and proton. Is right here. Negative sign tells about attraction between nucleus and electron. ठीक है, तो जितना ज्यादा ये वैल्यू होगा उतना ज्यादा अट्रैक्शन होगा. नेगेटिव साइन का मतलब कुछ इस मतलब इट इज नॉट नेगेटिव इन द सेंस कि कम और ज्यादा की बात कर रहा है. नेगेटिव साइन इज टेलिंग अबाउट द अट्रैक्शन. ठीक है, नाउ प्लीज सी. जैसे जैसे डिस्टेंस बढ़ता जाएगा पॉजिटिव और नेगेटिव चार्ज में, द केस ए वी हैव दिस डिस्टेंस, दिस इज द न्यूक्लियस. नेक्स्ट आपके पास ये बी केस है. व्हाट डू यू थिंक, वेयर इज अट्रैक्शन मोर, इन द ए केस और द बी केस? क्या ख्याल है, कहां पे प्रोटॉन अच्छे से इलेक्ट्रॉन को होल्ड करके रख सकता है, इन द ए केस और द बी केस? अरे हाँ जल्दी बताएं भाई, इतना आसान सवाल है. ए और बी केस में बताएं, वेयर इज प्रोटॉन द न्यूक्लियस एबल टू होल्ड द इलेक्ट्रॉन वेरी इफेक्टिवली, इन विच केस, ए और बी? काशिफ, सारा, सिद्दीका, यासिर, प्लीज लॉजिक लगाएं बिल्कुल 7वीं और 8वीं क्लास के बच्चों की तरह. ठीक है, आपको 11वीं क्लास के बच्चों की तरह सोचने की जरूरत बिल्कुल नहीं है. सोचिए 7 या 8 स्टैंडर्ड में रहते, कोई पूछा तो क्या बताते?
Sir, can you repeat the question?
Where do you think we have more attraction, in A case or the B case?
B.
B case makes sense, everyone? Yes or no, please tell me. Very straightforward. सिद्दीका, यासिर, काशिफ एंड
Okay,
वाटन.
repeat, sir.
क्या रिपीट करें हम? आप सुनिए तो ना, मेरी आवाज नहीं आ रही क्या? इसमें वॉइस नॉट क्लियर गाइस, प्लीज टेल मी. मेरी आवाज अगर साफ नहीं हो ना तो बोलिए कि सर आपकी आवाज साफ. इज माय वॉइस क्लियर? यस और नो, प्लीज टेल मी.
Yes,
Yes,
sir.
sir.
तो हम ये पूछ रहे थे ए और बी में से अट्रैक्शन कहाँ ज्यादा होगा, वेयर विल वी हैव मोर अट्रैक्शन? बी केस सबको नजर आ रहा है ना?
A.
ए केस क्यों? ए केस में तो दूर है ना चीजें, दूर में कैसे अट्रैक्ट करेगा? नजदीक रहेगा तब ना अट्रैक्ट करेगा. सिंपल सी चीज पूछ रहे हैं हम, आप पता नहीं क्यों उल्टा उल्टा जवाब दे रहे हैं बाकी लोग. अरे भाई जब कोई चीज नजदीक है तो ज्यादा अट्रैक्शन होगी ना. अच्छा आपको नहीं पता ये सारी चीजें, यू हैव नॉट सीन पॉजिटिव एंड नेगेटिव चार्ज. 10th क्लास में आपने करंट इलेक्ट्रिसिटी पॉजिटिव नेगेटिव नहीं पढ़ा है ना आप लोगों ने? एक बार बताइए, पॉजिटिव चार्ज नेगेटिव चार्ज के बारे में आपको जरा सा भी आइडिया है या बिल्कुल आइडिया नहीं?
We have.
You have some idea, right? अच्छा चलिए अब पॉजिटिव नेगेटिव छोड़ के मैग्नेट समझ लीजिए ना. मैग्नेट को रखा आपने ए और ए केस में देखिए दूर दूर रखा मैग्नेट को, बी केस में नजदीक रखा. वेयर विल वी हैव मोर अट्रैक्शन, ये बता दीजिए अब आप. बोलिए भाई, कहाँ ज्यादा होगा अट्रैक्शन, ए केस में, बी? बाकी लोग बोल ही नहीं रहे. हम अब थोड़ी हो गया बहुत, 10 बार पूछने का क्या ही फायदा, कोई बात ही नहीं कर रहा है. बी केस में ठीक है, जिन्होंने बोल दिया उनके लिए ठीक है. बी केस में ठीक है, बी केस में डिस्टेंस क्या था? डिस्टेंस था कम एंड डिस्टेंस वाज लेस एंड अट्रैक्शन वाज, वही हो रहा है. n is telling you about the orbit. If the value of n is lower, अगर n की वैल्यू कम है, 1 है, 2 है, कम है, then the energy of electron is higher. That means attraction between electrons and proton is higher. है ना? ये पूरा का पूरा चीज बड़ा हो जाएगा. एंड नेगेटिव साइन ये मत समझिए कि सर वैल्यू तो कम हो जाएगी ना. अरे वैल्यू बता ही नहीं रहा नेगेटिव चार्ज. नेगेटिव साइन इज टेलिंग यू अबाउट द अट्रैक्शन. कितना अट्रैक्शन अच्छा, बहुत नेगेटिव तो बहुत अट्रैक्शन, कम नेगेटिव कम अट्रैक्शन. इफ द n value is lower, this negatives complete negative value will increase, and that is why we will say that the energy of electron is higher and there is more attraction. नेक्स्ट केस आ जाते हैं जो बहुत ही आसान तरीके से हम पूछेंगे, एक बार ज्यादा नहीं पूछेंगे इस बार हम. I have here large magnet and here I have a small magnet. ठीक है, और दोनों जगह आपके पास एक छोटा सा मैग्नेट है जिसको हम अट्रैक्ट करना चाह रहे हैं. Here we have the A case and here we have the B case. Where do you think this small magnet will be attracted more intensely, in the A case or the B case? बड़े मैग्नेट से अट्रैक्ट, जी सारा?
A.
A case, right? So that is the analogy of the number of the atomic number. Yani ki atomic number is related to proton numbers. If I have here the proton number 20, so the attraction will be higher. A positive charge हो गया और electron में negative charge है. And here I have, let us suppose two protons, है ना, और एक electron यहाँ पे. So electron is attracted towards only, attracted by only 2 protons. यहाँ पे 20 है. So here you can see as the atomic number increases, this whole value will also increase, and the energy of electron will increase. That means the attraction between electrons and protons will increase. बात समझ में आ गई? हाँ या ना, जल्दी बताएं.
Yes, sir.
Now this makes sense? Yes or no? Please tell me. ठीक है? Now write next. Please लिखिएगा. The amount of energy required to remove the electron from ground state to infinity is called ionization energy. ठीक है, ध्यान से सुनिएगा जरा. Let's suppose, please don't write anything now. Here we have the proton and here I have the electron. And what is the meaning of ionization energy? We have to take the electron from ground state. Ground state का मतलब जो उसकी अपनी जगह, अपने घर पे था इलेक्ट्रॉन, उसको ऊपर नीचे आगे पीछे आपने नहीं किया. जैसा न्यूट्रल एटम में इलेक्ट्रॉन जिस पोजीशन में होता है उसी पोजीशन में. You have not supplied any energy, you have not taken any energy from the electron. Clear guys? Yes or no? Please tell me. Ground state. हाँ ना, जल्दी बताएं.
Yes, sir.
है ना. ग्राउंड स्टेट का जनरल मीनिंग अगर बहुत आसानी से समझना है तो आप समझ लीजिए फर्स्ट ऑर्बिट. हाइड्रोजन एटम की बात करें, बिकॉज बोर वाज ओनली एबल टू गिव द मैथमेटिकल एनालिसिस एंड एवरीथिंग अबाउट द हाइड्रोजन इलेक्ट्रोड और हाइड्रोजन लाइक एटम्स. ठीक है, हाइड्रोजन एटम और हाइड्रोजन लाइक एटम्स. तो उसमें हाइड्रोजन में जो इलेक्ट्रॉन रहता है दैट इज इन द फर्स्ट ऑर्बिट. अब फर्स्ट ऑर्बिट मान के चलिए. ठीक है, नाउ वी हैव टू टेक दैट फ्रॉम द फर्स्ट ऑर्बिट टू वेयर. कहां तक लेके जाना है? जल्दी बताएं, कहां तक लेके जाना है? अरे लिखा हुआ तो है
To infinity.
इंफिनिटी. पहुंचा दिया हमने इंफिनिटी यहाँ पे इलेक्ट्रॉन. If it is infinitely away from the nucleus, please listen to me what I am asking. If it is infinitely away from the nucleus, will it be attracted by the nucleus? या न्यूक्लियस का कोई इन्फ्लुएंस होगा ही नहीं उसमें. सही है. अगर infinitely away from the, if it is infinitely, अच्छा देखिए, नो है ना. अगर हम एनर्जी की बात करें ना, अट्रैक्शन तो देख लेते हैं हम लोग. E is equal to what? E is equal to -13.16 into what? Z square. Z ले लेते 1 square and n की वैल्यू क्या हो जाएगी? N will be equal to infinity ना, because infinitely away है. अरे मैग्नेट्स मत देखिए, अब पॉजिटिव नेगेटिव चार्ज देखिए. हाँ, मैग्नेट्स देख के भी समझ सकते हैं. हाँ ठीक है. हाँ, लोअर द n is equal to infinity. आप यहाँ पे infinity डाल दीजिए. E will be equal to how much? E will be equal to 0. सही है. हाँ या ना, जल्दी बताएं. If I am
Yes,
also
sir.
putting the values, ठीक है, इक्वेशन में भी डाल देंगे तो n infinity हो गया और E 0 हो गया. That means no attraction. सही है. That means दो स्टेट है. ध्यान दीजिएगा. The initial is E1 से E infinity जा रहा है. ठीक है, E1 से कहां जा रहा है? E. अगर आपको याद है यहाँ पे हमने लिखा था ना. हाँ, अगर 1 से 2 जा रहा है तो क्या होता है? E2 माइनस E1. ठीक है, अब यहाँ पे देखते तो E2 क्या है यहाँ पे? E2 is E infinity. E2 क्या है आपके पास? E infinity. That is why the energy required for this ionization will be equal to energy that is present in the infinite shell number minus E1, जो first shell में होता है. Now we have just seen that the energy or the attraction between electron and the nucleus at infinity is equal to 0 minus. What will be the value of E1? E1 will be equal to minus, if I am taking 13.16, 13.6 into Z square divided by N square, electron volts. Then first of all, this minus will be plus, and I will get 13.6. Z will be equal to 1 because we are taking hydrogen atom. N will be 1 because the value of N is equal to 1. And 13.6 electron volts will be the ionization energy for hydrogen atom. All of you got this? Yes or no, please tell me.
Yes, sir.
सबको आया? कौन भाग गया? काशिफ भाग गया. काशिफ के सर के ऊपर से जा रहा है क्या? यासिर also got. दोनों भाई चले गए, उनका नेट खराब होगा. ठीक है. Now this is only for, we'll say that this is ionization energy for hydrogen atom. In general, what is going to happen? Please see. N की value तो हमेशा 1 रहेगी ना, because ionization energy is defined as going from the ground state, that is the first orbit, to infinity. तो 1 N तो हमेशा 1 रहेगा. That means in general, ionization energy for an atom is given by ionization energy will be equal to 13.6. अब देखिए ये तो हमेशा 0 रहेगा क्योंकि इंफिनिटी तक ले जाना है. माइनस माइनस पॉजिटिव हमेशा हो जाएगा. N1 रहेगा हमेशा. So we'll get 13.6 into Z square electron volts. Got this? Yes or no, please tell me.
Yes, sir.
Yes, sir.
Yes.
Calculate ionization energy of helium plus ion. ठीक है. सिंपली आप हीलियम का एटॉमिक नंबर डाल दीजिए, आंसर आ जाएगा आपको. जल्दी कीजिए.
Sir, 27. Should I say it?
नहीं, तो स्क्वायर करना पड़ेगा ना इसको. हीलियम का क्या होता है? Z for helium will be Z is equal to how much? 2, right?
Yeah.
So ionization energy will be
Okay.
equal to 13.6 into 2 square. That is equal to 13.6 into 4 electron volts. 6 4s are 24. 4 3s are 12. 13 and 14.
54.
4 1s are 4 and 5. 54.4 electron volts. Got this?
Yes, sir.
कुछ चीजें हैं. बोर ने काफी कुछ एक्सप्लेन कर दिया था, but there were a few things that Bohr was not able to explain. एक हाइड्रोजन स्पेक्ट्रम बच रहा है बस आप लोग का. अच्छा, एक और चीज लिख लीजिए। Note, if the ionization energy of any element is given, then indirectly they have given the energy of their first orbit. कैसे जरा देख लीजिए। We know that ionization energy is equal to energy at infinity minus energy at the first orbit. Now, ionization energy आपको दिया हुआ है, and we know that E infinity is equal to how much? E infinity is equal to 0 minus E1. ठीक है, E1 कितना हो जाएगा? That means the
minus
energy of the first orbit will be equal to minus sign इधर चल जाएगा, minus of ionization energy. दिखा आप लोग को? हाँ या ना, जल्दी बताएं।
Yes, sir.
ठीक है, नेक्स्ट पीसी। अगर आपको यहाँ पे आयनाइजेशन एनर्जी दिया हुआ है तो दे हैव आल्सो गिवन यू व्हाट? दे हैव आल्सो गिवन यू द एनर्जी ऑफ द फर्स्ट ऑर्बिट, है ना? अच्छा, फॉर एन इलेक्ट्रॉन transitioning from first orbit to next higher orbit, तो बताइए इसके लिए क्या हो जाएगा? जो आपके पास here we have E is equal to, जो एनर्जी लगेगी यहाँ पे that will be equal to E2 minus E1, है ना? बिकॉज यहाँ पे आपके पास N1 क्या था? N1 was equal to 1 and N2 is equal to what? 2. Starting from 1 we are going to 2. So in this case E2 will be equal to how much? Energy of the second orbit will be equal to how much? Please see here. You have this formula, minus 13.6 into z square upon n square, है ना? यहाँ पे इसको लिख लीजिएगा। E2 क्या हो जाएगा? For let us suppose for hydrogen atom, it will be minus 13.6 into z will be equal to 1 divided by 2 square n का square था minus of 13.6 into 1 divided by 1 का square. As you can see, this is minus 13.6 divided by 4. Minus will become plus 13.6 divided by 1. All of these will be in terms of electron volts. Now, minus 13.6 into 4 into 13.6 divided by 4. सही है guys? No problem, right? This
Yes,
minus
sir.
became plus. Now I can get 13.6 common, है ना? और क्या मिल जाएगा? Oh, एक second. This is 13.6 plus होगा यहाँ पे. Common हो जाएगा 13.6 and I will get 1 plus 4 divided by 4. आपके पास आंसर आ जाएगा 13.6 into 5 divided by 4. ठीक है? And whatever this value will be in terms of electron volts, आप वो electron volts कर लेंगे. Is this clear, guys? Yes, no, please tell me how to get for the next
Yes, sir.
orbit. What else is there? बाकी तो कुछ नहीं है. I think this is enough. Then atomic spectrum and hydrogen spectrum, ये सारी चीजें हम लोग देख लेंगे. Just wait, you will have test, है ना? अब लोग test दे के जाइएगा. I don't know what happened to Kashif and all. Just give me a second. रिवाइज कर लीजिए जरा आप लोग। I mean, Learnivio in the, yeah, we don't have Learnivio in the meeting. Meanwhile, Learnivio is joining, तब तक आप इसको लिख लीजिए। हाँ, तो limitations भी हो जाए and everything will be covered from both sides. We are going to learn about the atomic spectrum in the next class. ठीक है?
So should we write this?
Write this. For limitations.
Done, sir.
Done? Okay. I don't know where these guys are. ठीक है. Okay. So Sarah, Siddika, and Martin. ठीक है सर. Have you given the test on app anytime?
Yeah.
आपने दिया. सिद्दीका आपने?
No, sir.
आपने नहीं दिया. मार्टिन आपने दिया टेस्ट ऐप पर?
Yesterday.
या टेस्ट या असेसमेंट? क्लास
Yeah.
असेसमेंट
Yes. Yesterday?
yesterday का पता नहीं हमको. yesterday तो आपने ऐप में नहीं दिया होगा ना. You must have given
No,
that
no,
in,
not on the app.
not on the app. You have the app, Siddika and Martin.
Yes, sir.
Please open the app. Please open the app.
Okay.
If you're on the phone ना, अगर आप फोन से ही Zoom के लेक्चर देख रहे हैं, so please keep your mic on, है ना? Otherwise अगर आप ऐप में जाइएगा तो माइक ऑन नहीं पाएगा.
Yes,
Siddika,
sir.
you're on the app, right?
Yes, I'm on the app, sir.
Yeah. Go to that three bars that you can see on the top
Yes.
right, right? And there you will, when you tap on that, you will see at the end class assessment. Do you see class assessment?
Yes, sir.
Do you see any
Oh.
current test list?
Yes, sir. I see the structure of atom Bohr's model
This model, right? So you have to attempt that test
right now.
right now.
Okay, sir.